b minus a in the denominator. If you don't mind, I'd like to write as 1 over b minus a times sigma. I just want to make it a little higher. Say there. Still this in the numerator, the sigma's in the numerator, the delta x is still in the numerator, and the b minus a essentially is still in the denominator, just written in a different form. Ready? Yeah? So, if I wanted not the sum of 10 ones, or 100 ones, or 1,000 ones, but really the average of all the ones, what would n have to be doing? Yes. So, I'm going to take a limit as n approaches infinity of this whole thing, and if you take the limit as n approaches infinity of this sum, just write it over here so maybe you'll see it better. We actually have an expression for this part of it. Just happens for you to recognize it. I have to say, all right, as n goes to infinity, what happens to delta x?
Small.
What happens to delta x?
Tends toward 0.
Yes. That limit as delta x approaches 0 of sigma f of x d delta x is actually replaced with what? This is the first fundamental theorem of calculus. First we learned it as Riemann sum, and then we learned it by that other method. This is the instead of this infinite sum, it's this infinite sum of f of x dx. Oh, it's not infinite terms.
Once again, boys, please make sure you take home your tefillin. Boys, please make sure you take home your tefillin. Everybody should have a Shana Tova, Metuka,
Average of all the ones
have a happy and healthy
is
New
actually
Year.
this infinite sum times 1 over 1, I would say. And in order to know from where to where, you have to be given from where to where, beginning and end of that particular question. So when you're asked to find the average value of a function, this is what you're going to include. Average value of a function. We just derived why this is the average value of a function. We started with a finite number of y's, y 1, 2, 3, 4 up to n, divided by n. Did a little manipulation with it, took an infinite sum of them, and you should now know when you see this symbol, it's an infinite number. One I was saying a few minutes ago, we're not going from 0 to 2 by saying 0, 1, 2. We're going 0.001. It's an infinite number. Every possible x value you can plug in, you plug in. It's doing it automatically. That's what that represents, that symbol for integration. I understand what we just did. But your faces don't say that. I'd like you to try that on a question now. I'd like you to find the average value. By the way, sometimes it's called f average. Same thing, f of x or y equals. For f of x equals sin s on negative pi to pi. Let's go right to the result of that whole derivation that's boxed down over there. What are we going to write? Let's
pi minus negative pi.
Catch up? I'm gonna see where he got pi and negative pi from. Okay? Go ahead.
The integral from negative pi to pi of sine of x dx.
That's all you gotta do. Like terms, yes?
Yeah, 2 pi.
Please don't write the integral symbol now. Once you're setting it up and you're integrating sine x, please don't write the integral of the answer. That's not what you're doing. That's like the student that does, what's the square root of 16? Oh, it's the square root of 4. No, it's not. So the integral of something, when you actually go ahead and integrate it, when you're at that stage, don't write the integral symbol again. Okay. So what is the integral of sine x, everybody? So again, I'm going to choose to factor out the negative out in front, just to kind of get it out of the way and make it less cumbersome. Minus pi to pi. And we're going to get an answer minus the answer. What's the cosine of pi? Picture the cosine curve. What's the cosine of pi? Anita?
1.
It is not. Then?
Negative 1.
It is. Cosine curve of okay, so now cosine of negative pi. Gosh,
Yeah.
2.
And the 1.
Yes, it is. It does the same thing from 0 to
Oh,
negative
no,
2
I
pi.
meant the same thing. I thought it was
Nope.
sorry, I meant they were equal to each other, and I said 1, and then.
Nope.
Anyway, what's the answer to our question? And that, in fact, is the average y value. Let's look at this picture.
That makes sense.
So glad you said that. Let's just see. We're looking at the sine graph, yes? From negative pi to, did I do this right?
Negative
Pi and negative
No, that's fine. Yeah.
Still, yeah. If you took the average of all the y values, a lot of y values here, a lot of y values here, why is it so clear that the average should be 0? The average of all the y values. Two people know. Take a lot of y's here, y. Y should be 0. Ruth,
Because they're all the same, except at the bottom they're all negative, and at the bottom they're all the same, values are positive.
so it's certainly reasonable that an average of all the y's could be 0. No problem with that. An average of another example might be negative or another might be positive. We understand what we just did. So you're going to remember here how to find the average y value. It's just a matter of going to that, circled equation. You're going to want to remember what that is. You don't need to necessarily remember the derivation of it. It would be really great if you understood all the derivations that I do, so you see where they came from. That would be great if you did. If you don't, then it's not the end of the world. Eric, you had a question?
Was there a reason you didn't box out the 1 over b minus x? Left-hand side, bottom left.
When? Oh, yes. I wanted you, when I was doing this, look over here, please. I actually said, I want you to focus on this part. And I was hoping nobody was able to recognize that this is an integral. That's why I boxed it out when I was doing it. This is still part of the rate sign.
Also,
Yes.
what is x with an asterisk on top?
I read it as X star, but it means C.
Okay.
It's just your book. Most books use the letter C. It's weird that they do it that way, but I wanted to just show you when you see it at home. Yes, Ben?
So all we did on average height was take the angle divided by the base, right?
Yes. Exactly. Does that make sense to everybody? If you knew the area, a great way to put it. If you knew this area and you divide it by the base, you're going to get the height, aren't you? very important point I have to make here. This is the average y value. There's going to be something called the maybe we did this already. The average rate of change. Do you remember that? Did we do that? Related rate questions. So dy dx represents. It's the instantaneous rate of change. Delta y over delta x represents the average rate of change. Like, for example, the change in distance over the change in time. We went from here to Albany, 150 miles, took us 3 hours. We're getting the average rate of change, 50 miles per hour. Yeah? Remember this?
Yes.
So if we needed an instantaneous rate of change, we have to find the derivative at 2.5 hours or whatever it was. But the average value is none of those. It's 1 over b minus a, the integral from a to b of x dx. So you may see the word average in the question. Don't jump to this if it's this. Don't jump to this if it's this. Yes? So average, I know what that means. So it's going to come up in 2 situations, sometimes near each other. I just want to make a point of the difference between them. Good? I'll take another homework question right now. Or, if you have a homework question from the previous lesson that I didn't have time to go over, I'd be more than happy to do that now. Questions? I'm ready. So sometimes we'll have time like this, and I hope you come up prepared.
Okay, so the integral of cosine of x dx from negative pi over 4 to pi over 4. Pi over 4, sorry.
That's it?
Yep.
Okay, so we need to get cosine x, what do you got?
So, sine x.
So what you gotta do is do the sine of pi over 4 minus the sine of negative pi over 4. What's the sine of pi over 4?
1 over square root of 2. 1 over square root of 2.
It is. And negative pi over 4. Just fourth quadrant.
Yeah, so it's negative 4. Oh, okay. I got it. It's not
Okay.
it's
You could say 2 over square root of 2, or you might say, you might rationalize it, you look for an answer that makes sense. Yes.
The absolute value of 2x minus 3 and dx from 0 to 2.
Integrate from 0 to 2. So you can see the key number here is 1.5. 1.5 is in this integral. So if we were to make a number line from 0 to 2, and list, so I'm not drawn to scale very well, but list the number here, numbers that are smaller, like 1-ish, absolute value would say I'm changing it. These numbers, absolute value leaves them alone. So for these values, from 1.5 to 2, you can just do 2x minus 3. But for the numbers between 0 and 1.5, you either have the absolute value to make it positive, which is what this would have done, or just negate it. Now I'm writing the negative of 2x minus 3 dx, but you could have written negative 2x plus 3, and it would be the same thing, of course. And that's it, just work on this guy, work on that guy, and you do.
No, you don't have to write like the whole thing.
You have to finish it. You have to integrate. Integrate 2x, you get x squared. Integrate 3, you get